Hi, all of you. Let's wait for 2 more minutes.
Laxman sir.
Hi, Abhishek.
Yeah, hello. Good evening, sir.
Good evening.
Sir, firstly, you will complete Docker or both you will.
No. First, Docker has to be understood in order to understand the Kubernetes. First, Docker will be completed. After that, we will begin Kubernetes.
Oh, okay, sir.
Yeah, hi, all of you. Welcome to this course on Docker and Kubernetes. Yesterday, we have discussed the concept of containerization. How the containerization technology was adopted in shipping industry for transportation of the goods, and the same analogy was taken in the containerization of the softwares. And if you remember, I have drawn a diagram. In this, let's suppose that this is hardware of memory about 16 GB. Let's take that. Okay, CPU. So let's talk about the only memory at this point of time. Okay, this is a general discussion. After that, in this, what we do, an operating system will be installed, and that operating system will be generally called as host operating system. And before the containerization technology came into existence, we have the concept of hypervisor, where we will install the hypervisor in the same host. This tool is nothing but what? Hypervisor. Hypervisor. This hypervisor will enable us to create multiple operating system within the same hardware. So that means our base operating system or our host operating system is Windows, and in that I have installed hypervisor. Now I can install Ubuntu in this. And in this particular case, if we want to spin up this particular operating system using hypervisor, we have to dedicate the resources for this operating system upfront. That means out of this 16 GB memory, we have to allocate some amount of memory to this particular machine. Okay, whether you use it or not, but that much of amount of resources should be allocated to this particular operating system. Okay, now what we are doing, we are installing some dependencies, and we are developing that particular application, and we are running in this. Ultimately, our purpose is to run this application, and we have to reduce the utilization of the resources by any other tool. That means our primary motive is to run this application once it is developed. But what if this Ubuntu operating system is consuming lot of resources? Only few amount of resources will be available for this. Okay, so now what we are doing is coming to containerization technology. Same thing, we will be having system resources here. In GB, and we will be having host operating system. It can be Windows or Linux or anything. And here we will install container runtime. In our case, the container runtime is Docker. Okay. So you have to understand Docker. What is Docker? Okay, that is yet to be understood as of now. So instead of hypervisor in this particular setup, when we want to use this particular container technology, we have to install a tool called Docker. And the same thing here also, our purpose is to launch another virtual machine. Okay, and we can run multiple virtual machines. Here also we can do the same. And when we are installing Ubuntu in this Ubuntu operating system is full-fledged operating system. That means if you go and if you search for Ubuntu 18 OS download, so this file will be of about if you go to that ISO file, somewhere it will be there. So it will be about 2.3 GB, right? About 2.5 GB, let's suppose that. Here, just to install this operating system itself, it will take about 2.5 GB of memory. And this host operating system, for this to be installed, it requires some memory, let's say 4 GB. And for this, let's say 2 GB or 1 GB is required for this. And for this, 2.5 to 3 GB is required for this. Ultimately, only few amount of or only a less percentage of system resources are available for our application. Okay, but coming to this container technology, we are installing this tool. Yes, it requires some amount of CPU and memory, but when we are creating these containers, this is called container. These containers will be using underlying operating system kernel. But here we are installing full-fledged operating system, and which also includes the kernel. We are installing the kernel as well here. But coming to this container technology, our intention is to run the same application, and we have to install the particular dependencies. But in this case, there is no need of installing full-fledged operating system. That means this container or this virtual machine will be utilizing the underlying operating system kernel. That means, let's suppose that this is Ubuntu machine. Okay, our base OS is Ubuntu operating system here, and in that we will be installing Docker. This is what we do in the real time. I will show you. And this Ubuntu kernel will be utilized by this particular containers. right? So this is the main important thing. From here to here, the difference is here we are dedicating the resources for this particular virtual machine upfront. That means when we are creating this machine, we have to allocate some amount of resources to this. But coming to containers, we don't need to allocate the resources to the container. The container or the application which is running inside this container will be utilizing the system resources as much as it is required. That is one thing. And in the container technology, for every virtual machine, we are not installing the full-fledged operating system. Instead, these virtual machines called containers will be utilizing the underlying operating system kernel. Okay, we may launch tens of hundreds of the containers within the same hardware, and those will be very lightweight because they will utilize the underlying operating system kernel, and of course the resources will be taken from the underlying hardware. So here it means what? We have saved a lot of system resources. Here it will be about 3 GB of size, but coming to here, we have Ubuntu operating system as the base image, which you will understand going forward. At this point of time, I don't expect you to understand this fully. And this size will be about 3 MB in size, or in some time just 1.5 to 2 MB. But this one is about 3 GB and this one is about 3 MB. So what is happening? Just for maintaining this application, we are using only less amount of system resources, but to run this application, lot of system resources are available for this application, which is our desire. Okay, and this thing. And one more point I want to make here is, you will understand how to create this container. That point of time, you will understand the difference between this and this. I hope that you already know how to install this particular Hyper-V or VMware and run this particular virtual machine. That's not a big deal. And to install this operating system, it will take about 30 to 40 minutes. But to install or to spin up or to run this container, it will take no time. That means within seconds, the operating system will be spinned up. But here, it will take about 30 to 40 minutes. Here, it will take about 1 to 2 seconds. Okay, and this is the thing. And one more point I want to specifically tell you here is, this container will be using the underlying operating system, right? So that means if any application is not able to be run by this particular underlying operating system, that also can't be run using the containers. Confusing? I will tell you this. Let's suppose that we have some application called application A. Forget about this container technology. This application A can be run inside this Ubuntu machine. Okay. If it is able to run in this machine, run using the containers as well. But if this particular application is not compatible for this underlying operating system,
this particular content, this application also can't be containerized, right? So you will understand what is containerization going forward, right? So this is the diagram. I want to just bring you to our notes. So this is the diagram that I have been explaining. This is the infrastructure, that is hardware, and in that we will be having host operating system kernel. In this case, we are installing hypervisor to spin up multiple operating systems within the same hardware, right? So if you observe here, we have to install full-fledged operating system that is as heavy as if we are installing that full-fledged operating system in a brand new hardware, right? So, but coming to here, we have eliminated the need for installing full-fledged operating system. Instead, these containers will be utilizing the underlying operating system kernel. And in this, we have to initially dedicate the resources upfront for this virtual machine. But in this case, there is no need to do that. Of course, we can put the restriction that we will see going forward, and especially in the Kubernetes, you will see that. Okay, and you can go to this theory. This is just example I have given. Then after that, how to install Docker. And before doing that, we have to be familiar with the terms which are associated with this container technology. So those things are, what is container? In general things, container is nothing but an empty box. But let's not use that definition here. First, let's understand what is Docker. Our course is about Docker and Kubernetes, right? So what is Docker? Docker is a containerization tool. Containerization tool. If it is a containerization tool, what is containerization? The process of creating containers is called as what? Containerization. The process of creating containers. Then what is container actually? Container is nothing but running instance of an image, more specifically in our case, Docker image. What it is? Docker is a tool for containerization of the applications. Containerization means the process of creating containers. If it is the process of creating containers, what is container? Container is an empty box. Here also the same thing will be there. Okay, it's an abstract layer over the application. But here our formal definition can be, container is nothing but running instance of a Docker image. Running instance means, for example, this is my machine. This is a running machine. That I can call as an instance. If you are aware of AWS, we will create the EC2 instance. If you are aware of Azure, there we call them as the virtual machines. Okay, these things are also virtual machines in AWS also. So one virtual machine can be called as one instance. And generally instance means there are multiple instances, means those instances will be running the same kind of application. Okay, that is in general terms, we will understand that. So here, container means running instance of a Docker image. What is Docker image? Docker image is nothing but application along with its dependencies, packed together in a file is called as what? Docker image. That means, let's suppose that we have Jenkins. We want to install Jenkins. How to install Jenkins? If you are from DevOps, you must be knowing that already. Otherwise, let's go to the official documentation of the Jenkins. Install Jenkins. Let's take Ubuntu itself. This is the official page of Jenkins. Let's go here. So installation of Java. First, Jenkins requires Java in order to run. So here in this case also, we want to run which application? We want to run Jenkins application. Jenkins is a CI/CD tool. Jenkins application. To install Jenkins in our Ubuntu machine, Jenkins requires some prerequisite softwares. Those things can be called as what? Dependencies for the Jenkins. For example, if you take a Flask application, it requires Python. If you want to install AWS CLI, it requires a Python, right? If you want to install the Ansible, it requires Python. Python is the dependency for that. Likewise, in order to run Jenkins, it requires some softwares. Those things can be called as what? Dependencies. For Jenkins, the dependencies are what? Java. Okay. And the Jenkins application with its dependencies packed together or bundled together in a file, then this file is called as what? Docker image. In other words, if you want to install some operating system, let's say Ubuntu, what we do? We have to download the image for Ubuntu. So the IO file, ISO file, this ISO file is nothing but what? It's image. It's image for the Ubuntu operating system. This image consists of multiple dependencies, software, and all those things, right? Once we install this image, once we run this image, then that will be called as an instance of Ubuntu operating system. Likewise, if we want to run Jenkins, Jenkins requires what? Java. So instead of installing the Java and other dependencies of the Jenkins, and so what's the general procedure? First, we have to install Java, and after that, we have to install Jenkins, okay, with these commands. But what we do in the containers is, we will, so for example, this is a development environment. What if I want to test this? In testing environment also, I have to perform all these steps, and there is a possibility of breaking. If the steps are broken, or if one or the other dependencies is missing, or if the dependencies of the QA environment are of different versions than that of the development environment, then there is a possibility of failure of the application, as we have discussed yesterday. To avoid this, what I will do is, I will pack the Jenkins application along with its dependencies, and what I will do, I will store this into some repository. I will store that into some central server. Those are called as registries. And I don't need to install these dependencies and everything in the other environment, let's say prod or QA or pre-prod or dev prod or UAT, right? So this box called image, we will ship this. We will ship this, shipping of the Docker images from one environment to the other environment through some central server. So coming to here in QA environment, I don't need to install the Java, I don't need to install other dependencies, and I don't need to do all those things. Just I have to run this box. Okay, so now the discussion is what? Docker image is nothing but the application along with its dependencies packed together in a file is called as what? Docker image. And this Docker image is just a file which is not running. This is just a file like our general file. Okay. Now, what I said, container is nothing but running instance of a Docker image. So this is Docker image. Once we run this, once we run this or execute this, this running instance will be called as what? Container. This running instance will be called as what? Container. Got it? So just we are executing that file. For example, to install some software like Helm, or let's say some tool, whatever the tool it may be. For example, let's say Putty or MobileXtorm or some Chrome. What we do, we will download a file that you can think of as an image. The downloading of the file is not sufficient. That has to be executed. So once it is executed, once the Docker image executed, we will get the container. And this process is called as what? Containerization. For that, we will use a tool called as what? Docker. I hope it is clear to you. Now, I said that these Docker images will be stored in some central server, right? So that central servers are called as what? Those central servers are called as registries. Okay, and more specifically, container registries. A Docker registry, we can call it as. Container registry is nothing but central server where Docker images are stored. Generally, the application source code will be stored in repositories like Bitbucket, GitHub, or Azure repos, right? So likewise, the Docker images will be stored in some central server called as registries. And the best example for the registries are one is Docker Hub and another one is Arbor. Arbor or Arbor spelling, I'm not sure about that. Then we have ECR. ECR, Elastic Container Registry, Azure Container Registry, GCR, Google Container Registries. Okay, so these things are also there. JFrog Nexus also we can store there, right? So here our point is to understand content registry. Registry is nothing but what? Some central server where Docker images are stored. We can't store them in the GitHub. They have to be stored in some special servers called as what? Registries, right? This is one thing. And to run the containers, we have to give the commands to Docker. For that, we have a tool called Docker client. Docker client is nothing but what? Docker CLI. Docker command line interface is nothing but what? Docker client, through which we will interact with the Docker engine, right? So when we install Docker, by default, Docker CLI will be installed, which you will witness in a few moments, right? So these are some of the terms that you should be aware initially. Now what I will do is, I want to create an Ubuntu machine in AWS cloud, because in real time, what we do, we will take some virtual machine in cloud, and if you are working with AWS, and it is EC2 instance. Let's run that. How to create EC2 instance? I hope that you already know. It's not that you have to run this Docker in the EC2 instance. No, you can have the Docker desktop also. For Windows also we have Docker, and but in real time we do in the Ubuntu operating system or some Linux distribution, right? So for that, what I will do is, I will just go to my AWS account, aws.amazon.com, sign into the console, and if you have Ubuntu machine anywhere, you can use that. And I want to log in as a root user, and this is my email ID, clouddevopscoach@gmail.com. Then I have to give the password. So I'm into Mumbai region, and if you guys are already aware, this AWS also launched the Hyderabad region also, just 2 to 3 weeks back, 3 to 4 weeks back. You can use that Hyderabad region also, but I'm using Mumbai region. Now go to services. I'm just quickly telling how to create a EC2 instance in AWS, and go to services, go to compute. In that compute, go to EC2, and you will see the EC2 dashboard. In that, click on instances here or here. Then click on launch instances. There are two types of graphical user interface for AWS. One is old experience, another one is a new experience. So in old experience, the things will be horizontal, you have to move forward, but here horizontally, vertically, the options will be there. Okay, but everything will be same. Just the look is different, as simple as that. Okay, let's not worry about that. Now, one more thing we have to observe here is, we have another term called Docker host. Docker host is nothing but the machine in which Docker is installed is called as what? Docker host. That means, for example, this is my Windows machine. If I install Docker, then that machine can be called as what? Docker host, right? So now what I will do is, I'm going to create an EC2 instance. I don't want to give any tags at this moment. And I'm going to this operating system thing. So here we will be having application and OS images, Amazon machine image. What I will do is I will choose Ubuntu, and more specifically I will choose Ubuntu 18, and which is free tier eligible. That means some compute capacity will be given free for us for 1 year if we have created the free tier account with AWS. So I'm choosing this. Then I will keep other things, architecture and other things default, because that is not a concern here. Instance type means depending on the type of instances, the system resources will be there. Okay. If it is different instance, the number of CPU and the memory will be different. So, but for the things, so T2.micro is enough, right? Then, so you must be knowing about the key pair, something like it's a key pair. And what I will do is I will try to create a new key pair here. I will name this as Docker classes, right? I will keep that, and I will keep everything default, and I will download the PIM file, create key pair. Just some people, they may not be having the Ubuntu machine, right? So if they want to create in the AWS instance, AWS account, this is how to create that. Just I want to quickly show you that. Okay, the PIM key has been downloaded, right? So then after that, select existing security group and select the default security group. This is not the part of Docker classes, so that's why I'm not explaining everything in detail, right? So this is, and I will keep everything default. Then number of instances I will keep only one. Then I will launch instance. You may have this Ubuntu machine anywhere, right? So it will take some time. How to connect to this remote machine? So generally, people may be using OT, but some people may also aware of that mobile system, which is very useful tool. So what I will do is I will go to just our documentation and how to download mobile system. Mobile system is nothing but some software to connect to the remote machines. Remote machines means the machines which are there in the cloud or some other environment, but not in the cloud, right? So just go to this URL. Hit enter. So you can download this. With this, a zip file will be downloaded. So if you extract that zip file, while it's taking time. Okay, meanwhile, let's go to this. Now this AWS EC2 instance is now running. The health checks are not completed. Now, let it go down the friends. Otherwise, show that in folder. So I hope that I have, let's suppose that we have downloaded that, we have extracted that zip file. So in this, if you double click on this terminal will be open. This is called as what? Mobile system terminal. Right? Now, how to connect it to that AWS EC2 instance? Click on this instance ID. Click on connect. Here, IP address, the public IP address, and the Ubuntu will be provided here. If you have having only private address, we can use the bastion host. That's part of the box. Just I'm telling. So this is the public IP address. Copy the public IP address. Open your mobile system. Click on session. Click on SSH. In remote host, paste the public IP address of that particular machine. and check the specify username box. What's the username? Ubuntu. If you are using Amazon Linux, the username will be ec2-user. Right? So Ubuntu is the username. By default, port will be 22 because we have selected SSH. If it is not there, we have to keep this as 22. Then where do we upload that private key? For that, click on Advanced SSH Settings. Then keep everything default. Then check this box, use private key. Once it is done, then this browse icon will be enabled. So before that, you can't browse it. Once you check this will be enabled. Click on that and go to our downloads. Just upload this particular Docker process key. Just click on OK. Went wrong. SSH. Copy the public IP address. Specify username. While starting the form actions of process, seems like let's exit from this. Because I have opened this LAN back. Okay, so this we have successfully connected to that remote Ubuntu machine, right? So in this, if you observe, see the SSH browser is also there. This is one good facility of this mobile stuff. Okay, that means whatever the directory structure that will be there, that you can browse through this UI also. Okay, so that's the thing. So we are currently in this. If you go back, if you want to go back to the other thing, you can go. If you want to add a folder, you can create that folder here itself. That will be reflected here. Okay, so this is the SSH browser. You can use that to work with the files of your remote machine. To enlarge this font size, just press Ctrl and scroll your mouse. Okay, with this, the font size will be changed. I think this is sufficient. Now, what we have to do, we have to install Docker. You don't need to go anywhere. You don't need to search anywhere. Just go to our nodes, right? Just switch to root user. So we are into root. Then just copy this command. Up to this only command, the people may try to copy and type this. That's enough. Just copy this. Okay. So with that, this output of this thing will be, this is a script. That script will be saved into SSH file in our local machine, and in that we have to execute that. How to execute that? Just access. How to execute shell script? Have to use shr.slash. So with this, what will happen? The Docker should be installed. Okay, so it will be installed anyway. So what I said, Docker host is nothing but the machine in which Docker is installed. Now the Docker is being installed in this. Once it is installed, I think it is done. It is done. How to check the Docker version? I said when we install Docker, by default, Docker CLI will also be installed. So with that, I'm checking the Docker version, right? So the Docker is successfully installed. So Docker is installed in this particular Ubuntu machine. So this machine will now become what? Host for the Docker, or that is Docker host. Now what I will do is I can name this instance as Docker host meaningfully. Okay. So in real time, what we will do is it's something like Docker dev or dev Docker host dev. You can name anything. Okay. It can be anything, friends. The instance name can be Ubuntu or anything. Okay. But meaningfully, we can give something like dev env Docker. That means this particular Docker will be utilized for the dev environment. For production, you may be having prod environment, and this Docker and everything, the Terraform can be integrated into the Jenkins, and we can trigger the pipelines. That is different story. So now our Docker is running in this particular instance, right? So now what we do is we have to run the containers. We have to run the containers. And if you remember, container is nothing but running instance of a Docker image. That means to run the container, we should have a Docker image and we have to execute that Docker image. If you execute the Docker image, then container will be created. Then where do we get the Docker image from? By default, the Docker community has already created some Docker images and it made those images available to the public. And those images will be stored in where? They will be stored in some container registry. And that public container registry is nothing but the Docker hub. How to check that? For that, just go to your browser, just search for Docker hub. Okay, so the first URL itself is that hub.docker.com. Okay, you don't need to have any account or anything at this moment. And we will also see how to create a private container registry in Azure or in AWS going forward in our course. Okay, that's what we do in the real time, right? We don't use this public Docker hub for storing our private images, right? So that is now. If you observe here, we have a tab called Search Docker Hub. In Docker Hub, what we search? We will search for the images, right? So, what is image? Image is nothing but the application along with its dependencies. What kind of application? The application can be Nginx server. The application can be Tomcat server. The application can be database. It can be MySQL database or PostgreSQL or MariaDB or any other database. Or it can be Jenkins application, right? Or it can be an Ubuntu operating system itself. We will see all those things going forward one by one. So now, for time being, what I will do is I will search for Jenkins. For that, you just have to search here for Jenkins. See, to search for Jenkins, about 10,000 results came for Jenkins. That means about 10,000 different kinds of Jenkins are there. Okay. So these are from different things. These are created by the rancher. Some are created by the Jenkins itself. And let's take the topmost one. Okay. And this in the top itself, the official images will be shown. So here, this is the thing, Docker official image for Jenkins, right? So here it is saying it is deprecated. Please use Jenkins :LTS instead of this. Where it is located? So in the below itself, it is there, or you can go with this particular downloads also. Okay, but you may be having different tags. One tag is LTS. You will understand the LTS tag, and this is the thing that we have to use. Now, click on this. This is what? Jenkins Docker image. Jenkins Docker image is nothing but what? Jenkins application along with its dependencies bundled together. That bundle is this one. So this is nothing but Jenkins Docker image. So I want to create a container from this. For that, what we have to do? We have to download this image into our Docker host. This is Docker hub, where the Docker images are stored. Okay, here Jenkins is there. Now I want to run the container. This is our Docker host machine. Okay, now Jenkins is stored in this particular registry. First, I have to download this Jenkins image into our thing, but Docker host. Once it is downloaded, this is image. Let's represent that this. The file is just downloaded. How to create container from this? I will represent the container with this symbol. How to run the container? We just have to execute this or run this. Once we run this Docker image, the container will be created. And inside this container, Jenkins application will be running. Now let's see that practically. Now, generally, how to install Jenkins in this Ubuntu machine? So first, these are the system requirements, hardware requirements, and software requirements are you need to have Java, and after that you have to perform all these steps, and there is no guarantee that finally Jenkins will be running even after performing these many steps. In the Java, so multiple Java things will be there, which Java is required, and all those things we have to take care of, right? So you know already how to install Jenkins, but with the help of containers, let's see how to install this, and we will see and we will witness the beauty of this containers now itself. Okay, so first this image has to be downloaded. For that, the command is docker pull Jenkins. This is the image, my friends, and we will be having tags. We will learn the tags going forward. So this is a tag here, right? So let's forget about that. If you don't give any tag, latest image will be pulled. So to perform this download operation, we will use pull. Docker pull Jenkins / Jenkins. Hit enter. See, pulling from Jenkins / Jenkins. This is generally a repository name, and the repository name along with some tag will become the image name. So the image will be downloaded as different layers, which you will understand later. So new image for Jenkins, latest image has been downloaded, right? Now, you must be getting some doubt. Where did we specify that this Docker image should be downloaded from this update.docker.com only? Have we specified anywhere? No. We just have switched to the root account. Wait, friends, my is making some noise. We just have installed Docker in this. We did not perform any activity related to the Docker hub. But still, if I use Docker pull Jenkins / Jenkins, the image is successfully downloaded. It means by default or by design, this Docker is integrated with the Docker hub. Okay, so by default, the Docker will try to pull the images from the Docker hub itself. So that's why the image has been successfully pulled. How to check whether the image is downloaded or not? Okay, here the status is given, but how to check how many Docker images are existing in our Docker host machine? For that, we have a command called Docker image ls. Stands for list out Docker images. Hit enter. See, we have the Jenkins / Jenkins. This is generally referred as the repository name. Repository is nothing different from the image name. Just if we add a tag to that, then that will become the image. Okay, we will learn that during the tags concept. And once it is downloaded into our local machine, the Docker will assign some image ID. This is a unique ID. And this was created 2 days ago. It's not created 2 days ago. It created a few years ago, but it was updated. That updated will also shown as created. Okay, and its size is 470 MB. Right now, this is the Docker image. For this class, I just want to run without explaining the command fully. How to run the Docker container from this Docker image? For that, we have a command called Docker run. I want to run a container from which image? Jenkins / Jenkins, and for time being, use which you will understand. My whole point of this is you will understand these things. We will just use run command to run the container from this image. You just please forget about this. Okay. Now let's see. Hit enter. See, Jenkins already running. How to access Jenkins? Jenkins port is 8080. Copy the public IP address. See how much time it took for us to run the Jenkins application using container within no time. As soon as I hit enter, immediately the Jenkins application started running. Right? So this is, I will give the same IP address to you. Please try to head this in your browser and tell me whether you are able to access. Quickly, please confirm. And here it will be asking for administrator password, which is already given in this logs. And or else it will tell where to go. We will see how to go inside the container terminal tomorrow. But for time being, let me copy the administrator password from here itself. So this is administrator password. So continue. Anybody try to access? Yes, Ahuja is telling it's working. Anybody in the world should able to access my Jenkins server because this is a public APIs. Okay, and that people also saying they're able to access. This is Jenkins, right? But how to install Jenkins without containers? This is the traditional procedure, right? So you should ensure that these are the system requirements, and you have to install Java and other requirements. And after that, we have to perform all these activities. You have to create some Jenkins user and all. See, do you give any guarantee for this? But using containers within no time, we are able to bring up the Jenkins server. That's it for today, friends. We will continue the session tomorrow at 8 p.m. Thank you. Bye. If you have any doubts in this class, today's class, you can ask me. And if anybody is having some doubts about the course, they can ask. So once you have paid, a Google Drive will be created for you. In that Google Drive, these classes along with the notes will be uploaded on daily basis. Okay. That's it for today, friends. Thank you. I hope it's clear. Some person, yes, they are saying it's working. Still everything is working. So I just want to terminate my EC2 instance because I'm not going to use this anymore. I'll just go here, click on instance state, terminate. Otherwise, we will be built. Of course, this is filter eligible instance.
Laxman, could you please share the notes for today?
Notes?
Yeah, the steps which you have taken.
Notes, I will discuss with the admins. They have to share with me the Google Drive link. So those who have paid, they will be created a Telegram group as well. And a Google Drive will be shared with you and with me. In that Google Drive, I will upload the notes. They will upload these particular classes. And on daily basis, I will be. So tomorrow, most probably, they may be creating it for the people who have paid for it. Okay.
Okay, and you said like demos will be there till Saturday, right?
Yeah, till Saturday, these things will be, demos will be there. And these, I think, publicly, these things will be available through some private link.
No issues, no issues. Yeah,
the video will be through email, right? Okay. Okay, friends. Bye.
Thank you. Bye-bye.